Hello friends, today's topic is full wave rectifiers. Full wave rectifier, its introduction, classification, advantages and disadvantages are to be discussed. Rectifier is a circuit, it converts AC to DC. Half wave rectifier converts half of the input signal to the pulsating DC signal. Full wave rectifier converts both the halves of each cycle of the input into a pulsating DC. The figure shows the block diagram of a full wave rectifier. Input is a sinusoidal wave, output is a pulsating DC signal. Types of full wave rectifiers are center tapped full wave rectifier, full wave bridge rectifier. First, we are going to see the center tapped full wave rectifier construction. It consists of center tap transformer, two diodes, resistive load. The first component, center tap transformer, similar to a normal transformer with one slight modification. An additional wire is connected to the exact center of the secondary winding. It divides the AC voltage into two equal and opposite voltages, that is plus V and minus V. The total output voltage is sum of the two voltages, V equal to VA plus VB. The figure shows the circuit diagram of a full wave rectifier. Transformer is a center tap transformer, two diodes D0, D1, RL. Input is in a sinusoidal waveform, output is a pulsating DC signal. Output voltage is VA plus VB, that is V, across the load RL. Primary and secondary windings. The figure shows the total operation of the full wave rectifier. During the positive off cycle, D1 is forward biased, we will get an output. During the negative off cycle, D2 is forward biased, we will get an output. So the total output is a DC signal. During the positive off cycle of the input, terminal 1, that is with respect to center tap and A, diode D1 is forward biased. That is terminal 1 is positive, that is A terminal is positive, center tap is 0 potential, terminal 2 B is negative potential. During the time, diode D1 leads to be forward biased. So once forward biased means the diode is act as a closed switch, cause current to flow through it. During the time, diode D2 is reverse biased, open switch, block current through it. During the negative off cycle, that is negative off cycle, terminal 2, that is B terminal is positive with respect to center tap. D2 leads to forward bias and cause current to flow through it. That is D2 is closed switch, current flow through it. During that time, center tap to A part is negative, the diode is reverse biased, it acts as an open switch, it will block the current through it. Figure shows the waveforms of the full wave rectifier center tap type. During positive off cycle, diode D1 conducts, and during negative off cycle, diode D2 conducts. As a result, both off cycles are allowed to pass through. Average output is almost twice the output of wave rectifier. So the figure, the left hand side is AC supply, sinusoidal positive off cycle, negative off cycle. The output is a rectified output waveform, that is both the off cycles are we are getting output, hence the name full wave rectifier. So the right hand side is during the positive off cycle, D1 current, only positive off cycle you will get an output. During the negative off cycle, D2 current. So the total output is D1 current, D2 current, total output is a pulsating DC voltage. Now we are going to see the second type of full wave rectifier, full wave bridge rectifier. Construction of full wave bridge type is It uses 4 diodes or more than it in a bridge form as shown in the figure D1, D2, D3, D4 load resistor input source. A full wave bridge rectifier system consists of 4 diodes and resistive load. Diodes namely A, B, C, D are D1, D2, D3 and D4 which form a bridge. The output is across the load pulsating DC output. Working principle of full wave bridge rectifier. The circuit is made as shown in the circuit diagram. Supply voltage AC is connected across the bridge. During the positive cycle of the input signal, terminal A is positive with respect to terminal B, that is terminal B is negative. It causes the diodes D1 and D3 are forward biased and the current will flow through it. That is, at the time positive cycle diode between A and D, but if the point A is positive, D1 is forward biased, it acts as a closed switch, current flow through A to D. Then at the time C terminal is positive, D3 is forward biased, closed switch, current flow through it. We are going to take the output between or across RL. We will get the positive cycle output. During that time, diode D2 and D4 are reverse biased. It will act as a open switch. It blocks the current through them. The current will flow from A to D, D to C, C to B. During the negative off cycle, terminal A is negative, terminal B is positive. It causes the diodes D2 and D4 to become forward biased and it will act as a closed switch. It will allow current through them. At the same time, diodes D1 and D3 will be reverse biased, act as a open switch. It will block the current through them. The current flow is from B to D, D to C, C to A, as shown in the figure. The output waveform is AC input signal. During the positive off cycle, D1 and D3 conducts, we will get the positive off cycle output. During that time, D2 and D4 are reverse biased, no output. During the negative off cycle of the input, D2 and D4 are forward biased, act as a closed switch, we will get an output. During that time, D1 and D3 are reverse biased, open switch, we won't get output. The total output is a pulsating DC signal. Characteristics of a full wave rectifier. The important parameters are ripple factor and efficiency. Ripple factor gamma is square root of Vrms by Vdc whole square minus 1. Rectifier efficiency. Efficiency is the output to the input, the ratio between the output DC power and the input AC power, eta equal to PDC by PAC. Advantages of full wave rectifier. Higher rectifying efficiency than off-wave rectifiers. They convert AC to DC more efficiently. That means low power loss because no voltage signal is wasted in the rectification process. The output voltage of center tapped full wave rectifier has lower ripples than off-wave rectifiers. Disadvantages. Center tapped rectifier is more expensive than off-wave rectifier and tends to occupy a lot of space. So far we have discussed full wave rectifier introduction, types of full wave rectifier, operation of center tapped full wave rectifier and full wave bridge rectifier. Advantages and disadvantages of full wave rectifiers. Thank you.